Mr. Adam is right?
Yeah.
Okay, so you have given me this, a piece of paper with 6 Pokemon on it. And you write lots of the basic stats.
Base stats.
Yeah. So then I translate this to here, right? So what's the advantage comparing to this and that? What's the advantage?
That one's more easier to understand.
This is more easy to understand.
The gender on there is not easy.
Yeah, this is an abbreviation. I just write G
that
from.
one takes less space than that.
That's space. Yes, that's a good point. Yeah, because look, for each one you have to write the attributes, right? Separate, right? The most important thing is that these data are here and there. It's not organized. This is organized. We talked about database last lesson, right? So these are organized. So I put all the data in a table, right? In the table, rows and columns. These are
We
rows.
haven't showed all the stuff like the egg groups, the evolution, the moves.
Yeah. There are 6
The
Pokemon.
name, origin.
Okay, yeah, obviously we can extend the columns. Right? These are the columns, these are the rows. Rows, for each row is a Pokemon. Each column is an attribute. Hit point, attack, defense, special attack, special defense, speed, gender. Okay, gender, the data you give me is a percentage, so 0.5 is 50%. 1 is 100%, okay? And then also there's a...
1 isn't it.
Yeah, also there's a total. Right? I didn't put total here because I think it's the total value can be computed here, right? For example, like this one, the total is 720. This one, the last one, 720. It's basically the sum of these, right? So there's no need to put a total here because if I change this value, I have to change the total, right? So this total value can be derived from those 6 columns. So if I put a total here, let's call the redundancy, okay, data redundancy. We ask computer to store the data in such format, in an organized way. This is also called relation database, relation database. RDMS, relation database management system, relational, yeah. So we can have different tables for storing different kinds of data. Okay, so look by this. So can you tell me which one has the most fastest speed? Which character? So what are you looking at? So which column? Speed. This one, right?
Yeah.
So this one, 120. If I only give you this, can you tell me which one is the slowest speed? It's not easy to see, right? But here, I can only look at this column. The slowest, this one. Yeah? You see the advantage, right? This is organized. So if we ask computer to do this, we have this SQL. Structure, query language, structured query language. So if I ask computer, tell me the name, okay, specific the name of the Pokemon who has the strongest speed, the fastest speed.
Arceus.
Arceus, yeah. So the computer could, first of all, it needs to look at this column and sort it.
The most fastest Pokemon with most fastest Pokemon out is Lucky, which I'm not showing there.
Okay, so maybe I rephrase my question. Can you ask the computer to sort the table by sort the Pokemon by the speed? Then we can ask computer to do this. Select. Okay, select. We can select something, right? Or we can select the column, select the name. Okay, let's say select the name, comma, and speed from, okay, this table, okay, let's say this table name is Pokemon. Pokemon, okay? Pokemon. From where? From this table. This is called Pokemon. Okay. And then if I do this, right, the computer will just return the name and the SP. You give us these 2 columns, right? And then I can say order by SP. Right, order by SP. Then you will rearrange the rows in such a way. Okay, the first one is 120. The second row is 90. 80, 75, 60, 50. Okay, order by default is ascending. Okay, so we have to specifically tell it descending, DESC. Okay, and we can say ASC. ASC is ascending, DESC descending. Look, this is one SQL select. So basically it has this format. Select something from something. Where something. Okay, I haven't talked about the where, okay? So I write another SQL and then you tell me what it returns, okay? Select name from Pokemon where SD equal 105.
Blastoise.
So what does it return?
Blastoise.
Blastoise, okay? Yes, because look, select name, I specifically ask for the name field from Pokemon, yeah? Where SD equals 105. Yeah, then you tell me this. This is the condition. I'm going to write something more complex, okay? I'm going to write where field. Where field. Select the name from Pokemon where D is smaller and equal than 100, right? And A is bigger than 80. Okay, so what does it give us?
It gives us Blastoise. And wait,
Yeah, Blastoise, yes.
Dragonite, Metagross.
Any more?
Dragonite, Metagross, Arceus.
Okay, so look, this one is okay, yeah? And then this one, D is smaller than 95, 100, yes, 95 is smaller than, A is bigger than 135, okay? And any other more?
Metagross. Or 135.
no, Metagross has defense. It can't be more than 100.
It should be less than equal than 100, right? Okay. So it returns two names, right? Two names. You can return multiple rows, okay? Select something, you can select name, HP, whatever, by doing this, yeah? Or you can, if you want to return all columns, we can give it a list. What do you call it? Wire chart, okay. Wire chart. So it means select everything. Select everything from Pokemon in order to return a table. This where statement, the computer needs to check row by row. And if the Pokemon has like a million Pokemon, then it's going to take time, right? Yeah, because that's linear search. Yeah, we talked about that. And we can add the index to it. Indexes. Right? So what's the index? Remember we talked about binary search tree, right? The binary search tree used to speed up the search. If it's bigger than 100, it's on the right. If it's smaller than 100, it's on the left. The same thing here, we can add the index up to a particular column. Then, different kinds of index. For example, the one simple way would be, okay, if the attack from 0 to 50, it's somewhere here. If it's 50 to 51 to 100, store it somewhere here. So if I say, okay, where attack is 35, then the computer will just look through the records in this bit, right? And not this bit, right? So we use the index to speed up the search. Otherwise, if the table does not have index, then computer can only do the search in a very stupid way, do it one by one, right? And if it's a million, there's a million Pokemon, it's going to be very, very slow, right? Because it has to check a million Pokemon to find out the criteria, the Pokemon which matches your criteria, am I right? Select something, we can apply some functions to it as well. For example, we can say select max. We want to select max attack from the Pokemon. Then you tell us it's 135, right? Max, mean, average, right? Those kind of function. This is called aggregate function or sum. Select sum, right? Select sum HP. Then you tell us it's this number added together. Right? That's one basic format of SQL. Select, very important. Select. Remember we talked about database to retrieve the data. We put the data here. We can use the SQL to retrieve the data, to query, structured query language, to query the database. Right? Select something from something, where something, order by something. Okay? Where something, order by. We talk about order by. Yeah? Make sense? It's easy, yeah? It's easy to understand, alright? Okay, I'm going to give a quiz, okay? We want to find out the name and the HP of the Pokemon where its attack value is bigger than the defense. How can we write the SQL? You don't need to look for it, just write the SQL. So how? Select name, yeah.
From
HP, yeah. From Pokemon. This is a table name. And where what? Attack is bigger than defense. So A is bigger than D. That's it. And then the computer will run through the records and find out the name and HP, which the attack is bigger than defense. So this one, this one, this one, yeah, there. That's it. From the record, we can order by. We can ask it to order by. Order by name alphabetically, or order by the A or D, right? Order by A or D or whatever, right? This is order field. So you can give a multiple columns. Order by these. If there's equal values, then we order by the second value, right? So this is how we query the table for this kind of thing. So yeah, you search the browser for the Pokemon, right? What is behind the scene? Basically something like that, right? This is one way, RDMS, one way of storing the data, but we have other ways of storing data, but this is RDMS. The other way would be, something like that, right? Store these here, there, right? It's not relational, right? Think this question we'll talk about in next lesson. If we want to store the fight, different Pokemon fight each other, right? Yeah? The result would be win, lose, draw, right? Am I right? So how would you do it? How do we store in this table, or is it better to do something else?
It's better to do something else.
That's right, because perfect.
Type advantages.
Type advantage.
Yeah.
What's type advantage?
Type advantages and type disadvantages.
Because
There's some super effective, not very effective, 4 times effective weaknesses,
because some Pokemon has weaknesses and
strength.
Okay, yeah.
Dragonite and Sliggoo, both are dragon types, and dragon is super effective against dragon, and dragon is weakness against dragon. And also it's the same for ghost. Ghost is super effective.
Okay, maybe I didn't explain the question clearly. What I mean is
and
that
there's also resistances.
we want to store the fight, the outcome of a fight between Pokemon. So it's better we don't mess up with this table, because this table is just stores the basic stats, right? We can extend the diff columns, right?
There's also
Basic stats of Pokemon.
no effects and immunities.
Yeah. But we can store another table called fights. Yeah, we can have another table called
Like
fights.
poison types have no effect on Metagross.
And for the type, we can have this Pokemon A, Pokemon B, and the result.
And
right?
also Vileplume is
You see what I mean?
and Blastoise since grass is super
Okay,
effective
right.
against water. Also Vileplume is a poison type.
Vileplume is not very effective against Dragonite.
Vileplume's poison types have no effect against Metagross.
Okay.
Ghost types have no effect on Arceus.
The point
Even
of this relation
even
database
Zoroark
is,
is only
come on, Ryan,
Zoroark,
listen to me.
Which is cool.
Okay.
And
So-
there's also immune to fighting, ghost, and
No
Yeah.
one.
Yeah. You done, yeah?
maybe.
Okay. My point is that we can store the
And
data
also
in different
Sliggoo
tables.
also-
We can store the data in different tables.
Sliggoo.
So one
Yeah,
table to
Dragon
store
and
the
Sea
basic stat of Pokemon. One table store the fight result. What else do you have in your Pokemon? Like
Strengths and weaknesses.
strength and weakness. Does the Pokemon have this equipment, buy the equipment?
No, Pokemon can't buy equipment, only the trainer can. And they use Poké Dollars. When you lose to a battle against another trainer, you need to give them money.
Yeah. When you fight a trainer,
And
and if you lose, you have to give $Poké to the winner, and if you win, the winner has to give you $Poké to you.
Okay, so there's a kind of items exchange,
and then you
right?
can use the money to buy Pokeballs, potions, escape rates.
I
And
see.
also, Pokemon can hold an item.
Oh yeah, Pokemon hold an item. So one Pokemon, how many items can it hold?
One.
Just one. Okay.
Well, if you want another item, you
You
have to get rid of the item they're holding and give
Okay.
them.
If there's only one item, then we can extend the column here, say the item, right?
And there's
But
also
if there are two
ability-
items, what are you going to do?
You have to remove one item. There's also ability. And some ability, Mega Venusaur has thick fat.
One question. If the Pokemon, I say if like, it can hold two items, So how are we going to store here? It's not easy, right? Because look, the problem with this table is that one column, rows, columns, right? If one, let's say if one Pokemon silicon has 2 items, how are you going to put it here? Item 1, item 2. Right? You're going to squeeze 2 data into one cell. Technically you can, but it's not very ideal. So in this case, we're going to decouple this. We're going to take the 2 items. We can have another table called Pokemon items. The columns will be Pokemon and item. Right? So we can have 2 rows, which is silicon, item 1, and second row will be silicon, item 2. You see what I mean? Yeah? Okay. Okay. Another thing I forgot to mention is the table. Each table usually have a primary key. So here, let's say primary key is name. It has to be unique. You can't have separate rows called silicon somehow here, right? Because primary key has to be unique. So each row represents a unique Pokemon. Yeah. Primary key is kind of like index, right? It's index. Also, it's unique. Okay, so to sum up, what have you learned today?
About Pokemon.
No,
Well,
Pokemon.
not really about Pokemon.
So you know about what? What have you learned? What's the takeaway today?
Database.
SQL.
SQL, perfect. This is the structured query language. Select something from somewhere where the criteria met, and we can have order by, right? This is a basic format. And we're going to talk about the join. The SQL can be joined. The select can be joined, right? We can select something from these tables. Now we just select from one table. We can select from multiple tables. For example, we can select from Pokemon and Pokemon fights or Pokemon items. We can join the table by some columns, right? Yeah. We can talk about that in more details in the next few lessons. Okay. Ryan, what have you learned?
Well, something
Something what? What have you learned? Come on, last question.
about database.
Database particularly is SQL, right? Okay? Yeah? Select a name from family where age is 10. Okay, so what does it give us?
Me.
Okay. Select the age from family where the name starts with R. What does it give us?
Me.
Select the age from family where the first name starts with R.
8
8.
and a half.
Okay. This is the SQL. Okay. That's it for today. Bye bye.